right, so we're going to try number 2, the polynomial x to the 5th minus 4x to the 4th plus 4x cubed plus 10x squared minus 13x minus 14. And again, we know that this has got 5 total solutions. So we're still going to start the same way by graphing it. It's just that in this one, if we're starting with a 5th degree polynomial, we're actually going to need to divide more than one time, because normally we had a cubed, and when you're done, you had that x squared. But now, if you only have one number and you divide by one number, you'd end up with an x to the 4th. I told you guys every time you divide, you go down a degree. So since we're at a 5th and we need to get to a squared so that we can either factor it or use the quadratic formula, 2 times we get you to an x cubed. 1, 2, 3 times would give you that x squared. So we need to find 3 numbers on this graph that we can divide by so we can get to a squared equation and either factor what's left or use the quadratic formula. So let's graph it. And again, just be making sure we're typing everything in. Don't mix up your minuses with negatives. Make sure you don't miss any exponents. And it is a long one, but that's okay. And then when you're done, you want to graph it. And then we're left here with this. So I told you that we need 3 numbers to divide by. But if I'm looking at my graph, I'm really kind of only seeing 2 places where it hits your x-axis. But I need 3 numbers. So here's the thing. At positive 2, where your graph or your polynomial goes through your x-axis, that does count as a solution. It counts as a single solution for your polynomial. But if you guys have these spots on your x-axis where the graph kind of comes up and just touches the x-axis, or comes down depending on which direction, and touches, if it just touches your x-axis, then they actually count as double roots. Like if you guys had an equation in vertex form, a parabola, that was like 3 times x minus 1 squared, but it didn't have anything added or subtracted at the end, the vertex wouldn't move off of that x-axis. It would have just moved left or right, but it's squared, so it counts twice. Like you could write x minus 1 squared as x minus 1 times x minus 1. So what happens is these spots where it just comes and touches counts as a double root, counts as the same value, but 2 times. So those numbers that occurs, in this case it's negative 1, if it's a double root, it counts twice. You can use it twice when you're dividing. So we know so far of your 5 solutions, x equals positive 2 and technically negative 1 twice. We still need to find the last 2 solutions. So it doesn't matter what you start with. You can do negative 1, 2, negative 1, negative 1, negative 1, 2, 2, negative 1, negative 1. It does not matter, but we're going to divide by those 3 numbers. So let's just start with negative 1. Again, be making sure we don't need any fillers. In this case, we have our 5th, 4th, 3rd, 2nd, 1st, and our constant. So no fillers here. So 1, negative 4, positive 4, 10, negative 13, and negative 14. So we'll drop down that first number and then multiply and add and multiply and add and hope that when we are done, we get no remainder or a remainder of 0. And negative 14 and 14 is 0. So we just want to keep building on what is left. Right now we've divided so that we're down to an x to the 4th, but we need to get to an x squared. So you can divide by 2 or negative 1 again. I'm just going to do 2. And multiply and add again until you get to the end. Just don't rush through it too much. Make sure you're not making any mistakes. I do sometimes. All right, we got a remainder of 0. That's good. So then the last one we need to divide by is -1 again. And we get another remainder of 0. So remainder is 0, 7 is your constant, -4 is your x, 1 is your x squared. So 1x squared minus 4x plus 7 is what you are left with, that you have to now find the two solutions that. We can't factor it, so we will have to use the quadratic formula. So a is our 1, -4 is our b, and 7 is our c. So we're going to plug them in. So x equals -4 plus or minus your b squared, so -4 squared minus 4 times a, which is 1, times 7, which is c, all over 2 times a, which is 1. So let's simplify it a little bit. Negative becomes 4 plus or minus 16 minus 28 over 2. (16 minus 28 is -12. Okay, so remember, your negative value underneath that square root becomes your I, but you still have to simplify the square root of 12. So we're not going to reduce 4 and 2 and 12 right now because you can't simplify numbers that are in a square root with numbers that aren't. So we're going to simplify the radical first and then see if we can simplify the fraction as a whole. So 12, you could do 3 and 4, 6 and 2. So pair of 2's are a perfect square of 2, and 3 is left. So 2 will come outside. And 3 is left underneath. So I kind of call it the heart check, but what you guys are seeing is if the whole numbers, not the number underneath the square root, not the 3, but the 4, the 2, and the 2, if those 3 numbers can all be reduced, then you need to reduce this fraction. In this case, they can. They can all be divisible by 2. So you would end up with 2 plus or minus 1 I square root 3 technically over 1, but you wouldn't have to write that. So if you really wanted to write these all out as the 5 separate solutions, just again, if you're visual, x would equal 2 plus 1i square root 3 to minus 1i square root 3, -1 twice, and positive 2. Those would be your 5 solutions to this polynomial. So the key here is remembering you have to get it to an x squared. So if you wouldn't be given this, but if you would start with, say, an x to the 8th degree polynomial, then you would need to find 5 numbers to synthetically divide by before you could use the quadratic formula. So you've got to get it down to an x squared, and then from there determine, can I factor this or do I have to use the quadratic formula to solve it? So you guys do have one to try. The next one, number 3, again, start with the calculator and see what you can pull from the calculator first.